Good evening, everybody. I'm Sean, and I'd like to welcome you back to another Tech Talk in our series sponsored by Codesmith, Jeeny, and Bractlet. Today, we have the pleasure of welcoming Brisa to give us a brief talk about TypeScript. So without further ado, I'd like to pass it on over to you, Brisa.
Thank you so much for the warm welcome, Sean. Hi, everyone. I'm Brisa. Thank you for coming. And I'd like to start by thanking Jeeny and Bractlet also for sponsoring this Tech Talk. Today, I'm going to be talking about TypeScript, providing you all with an introduction to what it is, how we use it, and if you, as a software developer, should even use it. So let's start with the first question. What is TypeScript? And now I know we're supposed to be talking about TypeScript, but you can't really talk about TypeScript without talking about one other very special language, which is JavaScript. So I want you to take a look at these two graphs from a JetBrains report on the state of the developer ecosystem in 2022. We see that there are a couple of languages listed in the graph on the left, like JavaScript, Python, Java, and etc. And it looks like JavaScript is the most popular here at 33%, and with TypeScript at 18%. If you look at the graph on the right, though, it looks like TypeScript has been rapidly gaining some popularity. That's for a couple of reasons, as might be reflected in this last graph that I'm going to show you. So while JavaScript is quite popular, it has also been mentioned the most often when it comes to developers' least favorite languages. So let's look into that a little bit. Okay, so hold on. What's JavaScript again? JavaScript is a dynamic and weakly typed language. If a language is dynamically typed, all of the checks are performed at runtime. So as you can see at the bottom, I'm trying to run a function cat, but only a dog function exists. I'm not alerted to my mistake until I try to run the file. And when I try to run it, the terminal tells me that there's a reference error and cat is not defined. And I'm sure that this type of error message is something almost all JavaScript developers are familiar with, but you know what could have prevented this problem? That's right, it's TypeScript. So TypeScript was created by Microsoft in 2012 to resolve some of the shortcomings of JavaScript. TypeScript, as opposed to JavaScript, is statically typed, meaning checks are performed before and during a compilation process instead of at runtime. Code written in JavaScript will run even if it contains errors that prevent the script from executing properly. That's why we only saw the previous reference error when I tried to run the file. But code written in TypeScript, on the other hand, will let you know if there's anything wrong with your code before we actually run the file. So as we can see on the bottom here, cat is underlined in red, and it points out that one, it can't find cat, and two, because it wasn't defined, it set the type to any, meaning it could be any type, and TypeScript wasn't sure of what it could be. That was just a small part of what TypeScript can do. And as we can see here, TypeScript is a superset of JavaScript. It adds a couple of things to make JavaScript more capable of creating larger applications that are easier to manage. So it makes sense why TypeScript is becoming more and more popular. Combined with JavaScript, TypeScript is portable, enables static typing, and adds some additional useful language features. We'll talk about these a little bit more in depth. So let's go to portability first. TypeScript is made to be ECMAScript compliant, and ECMAScript is a standard for how to create scripting languages like JavaScript and TypeScript. TypeScript compiles into JavaScript. Since JavaScript is the language of the browser, all modern web browsers support it, which means that you don't need to worry if TypeScript will run in your browser or not. And lastly, for JavaScript developers looking to migrate to TypeScript, any JavaScript file can already function as a TypeScript file. The logic doesn't need to change or anything. If you change the file ending from JavaScript to TypeScript, it becomes a TypeScript file. During migration, TypeScript will automatically assign variables and a function parameter or end function parameters to the any type with type inference, as you can see in the example here below. However, it's important to later properly define types in your code in order to fully utilize the capabilities of TypeScript. And speaking of types, let's use a monkey and banana analogy, my favorite type of analogy, to compare JavaScript and TypeScript. Let's say that JavaScript is a monkey. Let's just call him Mr. Monkey that's looking for bananas. He's really flexible and you might say dynamic in finding and grabbing bananas, but sometimes when he gets back home, he realizes that what he grabbed earlier was not a banana. He gets super frustrated and confused and he yells, and there he goes, he throws an error. And TypeScript is like a strict personal trainer for Mr. Monkey. He tells Mr. Monkey that, hey, before you go to grab anything, you have to say what it is out loud and you have to define the type and you got to stop and think about it, okay? So Mr. Monkey's like, okay, fine. And this prevents Mr. Monkey from grabbing items that are not bananas, and he goes home happy, always with what he expects, which are bananas. So in our case, TypeScript helps JavaScript define types and prevents it from using elements that are not the same type as a type of an expected element. In this way, we can catch errors much earlier on during the compilation phase instead of discovering them at runtime. And TypeScript has a couple of other useful language features in addition to types. As you can see on the left, the any type covers all the other type values. There are a couple of familiar ones here like string, number, Boolean, etc. I'm going to be focusing on two TypeScript specific features, which are interfaces over here and tuples. But I think it might be more beneficial to show you how we can use TypeScript with a live demo. So let me change my screen to the correct item. Okay, cool. Can everyone see my VS Code? Perfect. Okay, I can see you guys. Thank you. So here we have a function called music, and we're passing in a parameter genre. All this function is going to do is console log, I really like music, especially if it's, and then the genre. And then on line 4, we're going to be invoking this function with the passed in string alt pop. So over here, when I try running the file, let me make sure it's in the right file. Okay, cool. When I try running this file, it should console log the message with alt pop as the genre. Okay, perfect. So it looks like that's working. And then just for good measure, let's try doing rock. So console log that. Perfect. So it looks like our JavaScript code is working. But what if we pass in something like this? Technically, this doesn't really make sense. There might be a genre, I don't know, some niche genre out there that is a bunch of numbers. But we look at JavaScript and it's going to say, yes, I really like music, especially if it's this bunch of numbers. That's probably not what we want to happen. We probably want the genre to be a string, right? So what we're going to do is rename this little file and give it a TypeScript ending. And oh, okay, you can see that there are errors, but why are there errors? So let's go to our configuration file. So this is a configuration file that TypeScript needs in order to define what type of rules it's going to go by. And over here, we see that genre needs a type. It's right now assigned to any. In the configuration file, we have a property called no implicit any. If you set this to true, it's going to say, if there is an inferred type of any, it's going to throw an error. If we uncomment this out, we should see that error disappear. And yep, there it goes. If we roll over this, it just kind of tells us you should probably assign a type to it. So, okay, let's do that then. I'm going to turn this back on because we could always use a little bit more security. And the way that you do this in TypeScript is we want to assign genre to the type string. We type string with the colon, and that will assign genre to the type string. And then we also want to define what the function is returning. In this case, it's going to be nothing. So we will put void. And over here, we can see that, like it says, the type number is not assignable to what is supposed to be a string. And really quickly, if we try compiling this file, there's something called the TypeScript compiler that compiles it from TypeScript to JavaScript. If we try doing that, let's do this. It's going to throw an error over here. It will compile, but it's going to tell us during this phase that there's also an error. So let me delete that really quickly because that is not correct. And let's pass in what we're supposed to. So I don't know what to use already. Let's do EDM. If we try running this file and compiling it, we should no longer get an error. So over here, no errors, and it is compiled. And now we have clean code because TypeScript told us that, hey, your code is clean. You're expecting everything that you're supposed to be. You're good to go. So really quickly, let's go to arrays within TypeScript. Here we have a couple of arrays. On line 1, we're declaring a variable called number array and giving it a type of an array filled with numbers. So as you can see on line 4, we're assigning number array to a bunch of numbers, and you can have, sorry, that was a number. You can have any number of numbers in here. And then with incorrect types, these specific strings are not supposed to be here, as they say, because this array is only supposed to take in numbers. So we would theoretically correct this by deleting that and putting in only numbers, but for demonstration purposes, I would just leave this here so you can see what the error looks like. And there's something also really interesting with combining multiple types. We can use something called a union type, and we use the pipe symbol to kind of connect the two. So this is saying that this mixed array is going to be numbers and strings. So here are some numbers and strings, and we can see it's not throwing an error. And then over here, there are 2 Booleans in here, and TypeScript does not like that. It's screaming at me. So it's saying that the Boolean is not assignable to a string or a number. So I had to talk about arrays first before I talked about tuples, because sometimes people confuse the two. But tuples are arrays, but they only have a specific number of elements and types. So over here, we can see that the two nums is only supposed to take two numbers, like the name says. So there's 1 and 2. And on line 7, there are too many elements here. So there's 1, 2, and 3. And if we roll over this, it says that the target, which is two nums, only allows 2 elements and not 3. With an incorrect type, there's a string called hello. So it will say, I don't like that. Can't do that. Over here, you can also do mixed type tuples. So over here, I have a number and a string. This is correct because there is a number in the first one and a string in the second, which is dog. With an incorrect type, we have dog and cat. Unfortunately, dog does not make the cut. And then with num and string here, cat and number both don't make the cut because they are not in the same order. So that's also an important property to mention. And lastly, let's go through interfaces. So interfaces are a group of related properties and methods that describe an object, but they don't really provide implementation or initialization for them. So basically, just think of them as a set of rules for an object to follow. And also really quickly, when I compile this file from TypeScript to JavaScript, the interface will disappear because of the JavaScript file from the JavaScript file because its job is done. And we'll see that later. But for now, we can see that I have an interface here called person, and it has a couple of properties. So there's first name, last name, and location, which are all supposed to be strings. And then we have a visited property, which is supposed to be a Boolean. And then over here, we are declaring constant new person and assigning it the type of person and giving it values. So we can see that there is an error here. So let's take a look at that. So it says that the property location is missing in this type, but it's required in it. So conveniently, I've uncommented this line of code out, and we can see that the error is now fixed. And one more cool thing about interfaces is, as opposed to types, they can be reopened to add additional properties with something called declaration merging. So let's uncomment this. So this is the same exact interface. And over here, we see that there's another error. Now it says the height feet property is missing. So let's add a property called height feet with my height, which is quite obviously 7 foot. And there we go. So all of the errors are gone and we have a valid file. Let me try running that really quickly. So we're going to compile this TypeScript file into a JavaScript file, and then we use the TypeScript compiler again and compile that. It should give us a JavaScript file. And like I said earlier, the interfaces should disappear. And let's look, they're gone. Let's try running this JavaScript file. And what it should do is console log our new person object. And there we go. It console logged a new person object, and that is interfaces. And that's also the end of my demo. So let me switch back to my slides again. Can everyone see my slides? Perfect. So last question is, should we even use TypeScript? Seems like a lot of work. Okay, so depends. As with everything, there are pros and cons. One of the biggest positives is its ability to warn us ahead of time of any potential errors. We can correct the code before it's compiled and in this way improve code reliability. This is especially useful for large, complex applications, as less time spent fixing preventable errors means more time spent developing new features or optimizing processes. Also, if you're already familiar with JavaScript, the transition from it to TypeScript, like I showed you in the demo, is fairly easy to navigate. Personally, I believe that most of the learning curve was in figuring out the syntax for everything, but after that, it becomes really intuitive. But like in the picture on the left over here, at first it does seem incredibly verbose and you kind of don't get why we need it. For this reason, implementing TypeScript in a small application could be more work than it's worth. And it's also not completely bulletproof because it won't be able to catch logic-related bugs, only errors which your defined and expected types are mismatched. And lastly, TypeScript does have a necessary compilation phase, whereas JavaScript can immediately start running. However, most JavaScript applications nowadays require a build step with bundlers like Webpack or task runners like Gulp. So in summary, TypeScript is a superset of JavaScript, adding additional features to increase our code's reliability. And we use it by implementing said features into our code. And should we use it? It depends. If you're looking to reduce potential errors, strengthen your code base, and are making a more involved application, yes, I would encourage you to use TypeScript. If you're making something more simple where the code base is not particularly comprehensive, you may want to reconsider. And unfortunately, it looks like we are out of time for questions. I will show you my resources. So here they are. And thank you so much, everyone, for coming to learn about TypeScript with me. You can find me on GitHub and LinkedIn. My socials are here up on the side with a little QR code. And I'd love for us to be connected. But again, thank you so much. And I will pass it back to you, Sean.
All right. Thanks so much for that informative talk, Brisa. And thanks to all of you for coming out tonight. We'll see you at the next one.